What's up, everyone? I'm Luke Shapiro. We're here with
Kyle from DMG.
So I'm an orthodontist. Kyle's the digital specialist here at DMG. Today we're going to check out all the really cool technology that DMG has. I personally, when you think of DMG, you think of Icon, LuxAttempt, and I didn't really start thinking about them as a technology company until like the last few years. So let's see what they have.
Yeah. So this is the DentaMile 3 to Max, and it's our practice-sized offering for a printer. We tried to keep it compact and easy to use. It's got a lot of resins that it can use, and so what would you use a printer for in your practice?
I mean, I'm ortho, so mostly what we're doing is printing models, lots of models. We also do splints occasionally, starting probably to print the liners and more of like that flexible.
As the technology starts to get there. One of the features that the 3 to Max has is the RFID reader, so that lets the printer know what resin is inside the reservoir so that you never make a mistake.
Why does it matter what resin, like that the machine knows what resin it's using?
So each resin has to be cured differently, a different amount of light, a different amount of time with the light is on. And if you don't cure it properly, the material won't end up being cured properly. It won't be the right hardness, and it might break in the patient's mouth or just fail while printing. So it's important to make sure you're using the right parameters for everything.
And I guess before this, people were they putting in the resin and not having it in the right settings, would you say? Or
that did happen occasionally, like if you forget to change the settings when you create the job and send it to the printer, if you accidentally send the wrong settings, and a dumb printer, I guess, wouldn't catch that mistake. But this is one way that you can prevent any silly little mistakes like that.
Cool. All right, so now we're getting ready to print. And the first thing we're supposed to do is light calibration. Kyle, what is light calibration? Why is it important?
Yeah, so we're gonna do light calibration. I recommend it about once a week.
Okay.
And what we're gonna do is put this little holder in the machine, and then I'm gonna take my light sensor and connect it to the printer. Now, like I said before with how important parameters are and to use the right amount of light and the right intensity of light, this light sensor checks that the light is really what it says it is, right? This is making sure that the printer is actually projecting exactly 385 nanometer wavelength light at the right intensity. It's just going to make sure that your machine is always performing at its best and giving you the best and most accurate results it can.
And what happens if the light calibration fails?
The printer, it doesn't really fail. It's more so that the printer will just up the intensity until it's correct. So it can kind of balance itself out. So if it's supposed to be here and it's down there, it's going to bump it up a little bit to match.
Why would the light change? Is just the power of like a light bulb?
Yeah, it's kind of, there is a projector in here, so over time the projector is it's going to change in value. It's not always going to stay the same. It's mostly to keep your projector working over the course of years, That's why you do this once a week, because you're going to be using this printer, a couple times a week for a couple of years, and over time the projector is going to slightly change.
Is there like a lifespan of the projector? Like an estimate?
I don't know how many hours they're rated for, but
it's a long time.
It's a long time.
Okay.
Yeah, this printer's going on 4 years now, and it's still got the same projector. So.
And so when the calibration, if it needs to be calibrated, does it tell you, okay, we need to up the intensity
before
to do anything?
Before you start a job, it'll remind you hey, you haven't done light calibration in a while. You probably should. And then when you actually run through the calibration itself, it's just going to automatically adjust the levels to be.
Oh, so you don't have to do anything?
No, you don't have to do anything. It automatically adjusts it for you, and that's it. So.
And not every printer has this, right?
No, a few printers will have a sensor that can just kind of check the light and tell you if it's good or not. Yeah. Ours kind of goes the next step and will automatically adjust it for you.
And so comparing this to other printers, if there is no light calibration, they'll tell you what the light is, and then you just have to fix it yourself?
Or sometimes, really, even if you can't calibrate your printer, you're kind of just trusting that the light is the right wavelength and intensity, and there's not really a good check. The only way you're going to find out is when your parts start breaking, which is not how you want to find out, right?
So you're saying there's printers out there where you can't calibrate the light, you can't really check, and you're just kind of looking at the models to make sure they're being printed properly?
The lower end ones, yeah.
Another feature people talk about with this printer is the force feedback. What is force feedback? I mean, I'm thinking just by the name, there's a force that the printer applies and then there's feedback.
Yeah, pretty close.
Okay.
So force feedback is a patented technology in this printer, and what that does is it allows the build platform to sense the forces on the arm, right? Which initially doesn't sound that exciting, but this lets the printer know when it is pushing against the bottom. It lets the printer know when it's separated from the bottom layer, which is really important because, right, every layer we're going up and down and up and down, and every time we go up and down, we have to make sure that we are separating from that bottom layer, right? A lot of other printers don't really have a good way of telling when that separation has occurred. So what they'll do is they just move, really far up and assume that the separation has happened. Since this has force feedback, the moment we separate and that we pull that part off from the bottom, the machine feels that. It's kind of like pulling a suction cup off of the wall or something. You feel that and it pops off. Now the printer knows, okay, I've separated, I can go back down right away. So it actually speeds up the printing process quite a bit.
So it's just a time saver.
Yeah.
How much time would you say was saved through the force feedback? Can you estimate?
It depends on which printer we're comparing it to.
Yeah.
But versus a printer without force feedback, maybe a second or two a layer over 200 layers ends up being, 2 to 5 minutes on a print that would have been 20 minutes,
It's really like a speed thing.
For the most part, the printer can, like I said, recognize when it's on the bottom.
Yeah.
So when it goes to start that next layer, it moves down until it feels the bottom.
Cool.
So it does kind of help with reliability as well.
But do you know when the DMG printer, or they've always had it?
Yeah, the Freedom X and our other machine, the Lab 5, have always had force feedback. So,
Okay. So you're saying,
start.
so every other printer, they basically have to go up a certain distance to make sure it's definitely separated, and then it goes back?
Yeah.
Okay.
Since force feedback is patented, no other printers have it. So how has 3D printing affected your practice?
Yeah.
How has it changed how you work?
So, I mean, for me, 3D printing is kind of like a necessity, because if you're not 3D printing, then you're taking impressions and you're pouring up models, which you don't really want to do. So yeah, basically now you have to print if you want to keep things in-house. If you're not printing, then you're sending it out to a lab. You have to wait for the lab to print it. You're paying money for the lab, and there's all these other, things that you now have to deal with if you don't have a printer in-house to print things. Sometimes you need to have things rushed the same day.
Yeah.
So you print out a model, takes 30 minutes, and then you have to do the suck down. And also back in the day too, I feel like the printers were much more, they weren't as user-friendly.
Yeah.
And now it's just so easy. You just kind of click a couple buttons and most of the settings are already dialed in for you.
Yep.
Back in the day, you had to choose, okay, this model has this setting, you have to have these supports, you have to have this amount of cure time, exposure time, and you really have to dial in your settings to get it perfect, and now it's just...
Yeah, that was like the RFID feature I showed you earlier, right? When I scan the bottle to the printer, it just kind of takes care of the rest, and I can do the same thing with my wash and my cure. I just tell it what resin I'm using, and it takes care of all the guesswork.
Exactly. So. Yeah, look, I'm a dentist, I'm at the chair mostly practicing. I'm honestly not really printing myself.
Yeah.
So we really have to teach the team in the lab how to do everything. They honestly probably are better than me at working these machines, but I have to have a general concept and understanding, knowing what it's capable of and whatnot. So yeah, it just has to be something super easy that your staff can do and kind of takes care of yourself. And you don't want your staff to also have difficulty. They have a lot of things to do.
Mm-hmm.
So you just want the printer to just kind of work by itself and
do its thing and act like another employee.
Yeah.
So what's your communication like between, you said you have your in-house lab guys, right?
Yeah. So basically, we take a scan at the chair, and then some of the scanners, they can send directly to the lab, or we have to download the STL file and then send that. And then the lab, they'll basically take the STL file and they'll put it on the computer software to put it on the printing platform, and then they'll print it. Mm-hmm. So I'd say from scan to them probably takes let's say 5-10 minutes.
That's pretty quick.
And then they print it.
Yeah.
Next stop is washing and curing. Why do we have to wash it? Why can't you just like take it right out from the printer and have it be ready?
Yeah, so you might have seen in the close-up, but once we take our part out of the resin, it's kind of covered in that sticky resin, which if you've never dealt with resin, kind of has the consistency of like honey, right? We have to get all of that material off so that we can, deliver it to the patient, right? So the first step is washing. And for washing, most systems are just going to use regular isopropyl alcohol, and that's going to dissolve away the excess resin and just leave us with a fresh, clean part. It has agitators in the bottom that are going to spin that alcohol around and really wash your part off for you.
Okay.
And it also has 2 bottles in this tower over here that are going to clean it through twice. So it's kind of like if you have some really dirty dishes, right? You're not just going to immediately throw it in the dishwasher or something. You might rinse it out first and then use the soap. That's kind of the same idea with a 2-stage wash, right? We're going to wash it with 1 bottle, which tends to get dirtier the more you use it, and then the second bottle stays a lot cleaner.
How long do you leave them to be washed for, would you say, about?
Every material needs to be washed for a different amount of time, but that's what's so great about our system is that all of those times are programmed in. So, right, all I have to do is put my part in the wash, find the resin and hit play, and it'll wash for as long as it needs to. Most of them are 5 to 10 minutes.
What if you put it in a wash and to get washed, and let's say you forgot about it and overnight, it's like 24 hours of alcohol?
So alcohol can start to seep into the part, and once it absorbs, it's kind of like your fingers when you're in the bathtub for too long, they get weird and pruny. The part can do the same thing, and when that happens, the part can be, it'll be weak, it won't do what it needs to do, and it can deform as well. So if you're doing dental work on it, using it as a model, it might not be accurate, or if you're using it as an actual wearable device, it's going to be more likely to break. So this part is great, or this wash is great because it pumps the alcohol in, cleans it out, it pumps it out, and you can leave it there overnight because it's not sitting in the alcohol.
So you don't have to worry about like changing the alcohol here?
You still do, but just less frequently because of that 2-stage wash, right?
How often should you be changing alcohol?
It's about once every 20 washes, which depends on, that depends on how often you're going to be washing. For me, that ends up being about once a week. I come in on Monday and I clean my alcohol out.
And what happens if you don't change it every 20 days? Let's say it's been there for like 6 months.
Well, your alcohol will get saturated with all that excess resin, and it won't be very effective at cleaning the part out. So when you take the part out of the wash, it'll still be kind of sticky and covered in resin.
So now that we just washed it, next step is curing.
Yeah, so you might think, why do we have to cure this part when it's already printed? Shouldn't it be done and good? When we print it, we're not actually fully curing the material because it would take much longer, and it would also be a little bit more likely to break. So this part is actually a lot softer than it's supposed to. You can see how I can kind of flex it a little bit. So we're gonna put this in the cure, and that's gonna hit it with even more UV light to get it into the final prepared stage. Make it as hard as it should be, and that way it won't break and it'll behave like it's supposed to.
I've seen some curing units where it's just like a box with a light
and a rotating platform or something. Yeah. So those will get the job done because at the end of the day, to cure, all you need to do is hit it with the right amount of UV light. But if you cure in the presence of oxygen, you'll actually get a little bit of a film on the surface, which is called an oxide layer. It's actually the same reaction as just rusting steel. So one thing this cure does is it pumps out the oxygen with a little vacuum pump. You might have heard of other systems using nitrogen, right, where you pump in nitrogen. That does the same thing, or even like soaking the part in glycerin. It's all the same thing, which is just keeping the air out of the cure chamber. And for me to cure, all I have to do is put it in here and select my parameter. And
so I'm guessing same thing, has the exact parameters you need so that you don't overcure.
Yeah, all I do is tell the cure which material I put in there, hit play, and it'll cure it for exactly the right amount of time. I can get that started here and we'll move on.
All right, so we got the final product here, just moved out by Kyle.
Yeah, so printing that splint specifically was 20 minutes. The wash was 10 and the cure was also about 10. Then once it comes out of the cure, you have to remove all the supports, which they break off pretty easy. And then you can use a pumice on a wheel to polish it up to however you'd like.
Yeah.
You know. So all in, you can do the model, or you can do the splint in about an hour and 10 minutes from starting the print to what you have in your hand.
Yeah. And the nice thing too, you don't have to print a model with this as well.
Yeah, it's a modelless workflow.
What's this printer called again?
This is called the DentaMile 3D Max.
Okay. And this system here is called?
This is the 3D Wash and the 3D Cure.
Okay. And this is basically what you guys recommend for dentists, right?
Yeah, we also have the Lab. The Lab 5 is more of a lab-focused machine with a higher build volume, and the MC5 is a smaller but good entry-level system that's really good at printing clear materials if you're just focusing on like your splints or bleaching trays, whereas this has a lot more options in terms of the resin availability. So if you want to be able to do everything, but you only need a couple models a day, then the 3D Max is a great printer.
People will say, what's the best printer? I feel like there's not really a best printer. It's like, what's the best printer
for you
or
for your practice? Yeah, right. Like, what's important to you? Is it speed? Is it how many models can it fit in one job? Is it just printing crowns? Right. Every printer is going to be different.
Awesome. Well, thank you. It's been fun.
Yeah. Thanks.
All right. See you next time.